Youngstown, Ohio, smack in the middle of America's Rust Belt. So how does a city built on old school manufacturing fit into our tale of the digital thread? For help with that answer, I turned to Rob Gorham and his team at America Makes, the National Additive Manufacturing Innovation Institute. The work they're doing around additive manufacturing is helping drive Youngstown into the future.
With additive manufacturing and being a process that deposits material and builds parts three-dimensionally, layer by layer, it really allows you to add features and complexity that you really can't get through traditional machining and other manufacturing processes.
All right, well, I really appreciate your taking the time to walk me through this.
No worries.
What are we looking at here?
So we know from the topology optimization that it structurally should hold up, but it's my job to make sure that it prints correctly so it is what we think it will be.
Chris Barrett is a factory fellow at America Makes. He's going to help us bring our digital part into the physical world.
What I look at it and I see is kind of these features that are flat on top and then on the bottom. And so one of the things that I first have to remember is I've got to get this part back off of my build plate.
Okay.
So already I don't want to weld this directly to there because then I'm going to have issues with this gap here. So I need to raise it up just slightly. And now I have a little bit of a gap down there so that I can come off with a bandsaw or a wire ADM and somehow get it off the plate.
Okay. Without affecting the part itself.
Without affecting the part. Because they've already done all of this work to perfectly optimize this part. They don't want me to come back in and mess it all up.
Okay.
Yeah. So now I run into the issue that the part is off the build plate, so I have to actually support it somehow. So what I'm going to do is I'm going to add some supports in there in that feature.
Okay, so this is all essentially infill, a lot less dense, because its only function is to hold up the part while it's in this molten state.
Correct.
And then in post-processing, we're going to machine all that away to leave us with the part as it originally looked.
That is correct. So if I zoomed in on here, you would see this is just a very light mesh. And so it would allow, depending on what we need to do, either to CNC it off or to come back with a Dremel and touch it up or something like that. So now what I'm looking at is I'm looking at it kind of layer by layer. So this would be all the supports. You don't really see a part.
Yep.
If I scroll up just a little bit, you'll see the black. That's my actual part. So it's kind of building it up layer by layer as I go through
And I can analyze each layer now of the build in order to make sure that it's going to look like...
Correct. Yeah, so I will go through and I would look at this and I would make sure that there's nothing missing. You know, the software didn't generate any issues or anything like that.
It's like an MRI. It looks
exactly.
Like
it's actually the same technology that's been done in MRIs, and I can take an MRI scan and utilize it in 3D print a model off of it.
Does this work like translate to the next time, or do you have to redo everything every time?
No, that's a great question. So a lot of times for a complex part, for qualifying something, especially for an aircraft part like this, we would standardize the build envelope. So I would create one with the proper layout of however I was going to do it, and then I would lock that in and save that file.
Okay.
And that way I would print that same file every single time with no moving parts.
So one advantage of then having this notion of the digital thread is that I create this repository, this body of knowledge. Yes, I might have to engage in a high level of technical examination the first time through, but for those future iterations, I can get a lot faster and therefore a lot more productive.
That is correct, yes.
Okay, so we've got our selective laser melting or SLM machine here.
Yes.
We're ready to print?
Ready to print, and this is the file we were just looking at up there. One of the things we've done with this machine is we've mounted a sensor inside. So we will take this part and we'll put it through the normal traditional tests like a CT scan and all that stuff after it's built. But we've also mounted a sensor inside for what's called in-situ monitoring.
Okay.
And what that's going to do is it's going to analyze every single layer for this entire build, and then we can look back at that data afterwards.
So we're literally going to watch this thing get built layer by layer. We're going to pull all that data off, and we're going to inject that into our inspection protocol.
Correct.
Once we're done.
So once we're done, we'll be able to, just as with this file, how I can scroll through layer by layer to see all the different layers, we would be able to do that same thing with this scan data.
Cool. Ready to go.
Yep, build plan is all set. So the only thing really left at this point is just to hit start. So
can I do that?
Absolutely.
part is built layer by layer overnight. The next day, I meet up with Chris and Dr. Brett Connor. Brett is the director of the Advanced Manufacturing Research Center at Youngstown State University. He's going to walk us through what happens after the print is done.
He's gloved up and he's wearing his respirator and he's wearing a fire-resistant coat. And we're doing this because we're working with metal powders.
Okay.
So we want to prevent respiration, we want to prevent getting it onto the skin and so forth.
Even into his skin, it could be with this particular...
It could be, it could cause irritation or something like that. This particular powder is relatively benign, but better to be safe than sorry, so we wear the personal protective equipment. So this is really the first step to what we call post-processing. We're going to excavate the part, remove it from the machine. Then we're going to do the next series of steps to get to the final material properties, the final geometric dimensions, and make sure that we're within the tolerances required and the surface finish.
It looks like he's almost done. Can we take a look at the part?
Sure. Once he has it done and the powder's kind of settled down, then we can come in and take a look at it. And you can see the part is now up. It's up to level now. And you can see that there's these supports that are holding the part in place, and any overhanging structure is supported.
How's it look to you?
It looks great to me. One of the first things I look at is to see if it peeled off of the supports for the plate, and that all looks great.
Okay.
So we had a good weld from what I can tell. So the next step would be to post-process it and see how it looks.
Perfect.